Okay, now let's have another look at our coroutines example. When we run it again, you can see that both coroutines start their work, then they perform the work concurrently, and afterwards they both finish. Okay? So you might ask yourself why we actually need coroutines here to achieve this kind of behavior. We can get code that is running concurrently with regular threads too, right? So why should we use coroutines? Let's now try to implement this example with threads. Let's copy the file oneroutines.kt and paste it again and give it the name 3routines threads. Let's first rename our function from routine to thread routine. Otherwise, we would run into conflicts because we would have two top-level functions with the same name. Then, we also change the call site so that the proper function is called. We also add a thread.sleep after the function invocations in order to wait for the threads to finish. And now every time we run this function, we want that the body of this function is executed in a new thread. Therefore, we can use the convenient thread function from the Kotlin standard library. Let's now run this example. As you can see, we get the same output as in the coroutine example. So why do we need actually coroutines when we can achieve the same thing with good old threads? Well, threads have some disadvantages when it comes to efficiency and performance. An allocated thread object consumes a considerable amount of memory, and switching between threads is a very expensive operation. In our coroutines example, however, we were able to achieve concurrent behavior without creating new threads and switching between them. Everything is executed on the same thread. You don't believe me? Well, let's go to our example and just print out the thread on which the coroutines are running. So let's close this console output for now and copy paste our coroutine example and call it for coroutines with thread info.kt. Again, we rename our function to, let's say, coroutine with thread info to avoid conflicts. To the print statements in the suspend function, we are now going to add some more information about the name of the current thread on which the coroutine is running. Now let's run the code. As you can see, both coroutines run on the same thread, the main thread. So we are indeed able to write concurrent code with coroutines without switching threads. When learning about Kotlin coroutines, you will often read that coroutines are lightweight threads. I now want to show you a classic example that showcases this statement. Let's create another file called 5 starting lots of coroutines and create a main function there. We use the run blocking coroutine builder for the body of the main function. In the body, we use the launch coroutine builder to start a new coroutine. Again, you will later in this course learn all about the coroutine builders like run blocking and launch. All that our coroutine will be doing is at first delay the execution for 5000 milliseconds and then print out a dot. Let's run this app now. It should print out a dot after 5 seconds. Yep, and this is probably one of the most boring examples you have ever seen, right? Until now. Because the next thing we're going to do is to not only start a single coroutine, but 1 million coroutines. Yes, you heard right. Therefore, we use the repeat function to run the code that starts this new coroutine for 1 million times. Let's now run this not so boring anymore example. As you can see, 1 million coroutines get launched that each print out a dot. You don't think that it's actually 1 million dots? Well, then let's count them. 1, 2, 3, 4. Just kidding. Let's select all of them and copy-paste them into the text editor Sublime Text. When we highlight all of them, Sublime shows us the amount of characters we highlighted in the bottom left corner. And voila, 1 million. So executing 1 million coroutines, all on the main thread, wasn't a problem at all for my machine. Let's now try how threads are doing. Therefore, let's copy the coroutines example and paste it again and change the name to 7 starting lots of threads. In the main function, we don't need the run blocking coroutine builder anymore. Then we can delete the launch coroutine builder and replace it with the thread function in order to create a new thread. In the thread lambda, we now replace the delay function with thread.sleep. We have to do this because we cannot invoke the suspend function delay from a regular function, as you have learned in the previous lecture. Now let's execute this code. After a few seconds, boom, the main thread shows an exception. java.lang.outofmemory error. Unable to create new native thread. So at some point, the system ran out of memory and wasn't able to allocate an additional thread anymore. This example illustrates that coroutines are indeed very efficient and lightweight. We were able to run 1 million coroutines on my machine, but ran into an out-of-memory exception when creating 1 million threads. This is because threads need a significant amount of memory, and when you allocate lots of them, at a certain point, you will run out of memory. So this was a free video from my online course called Mastering Kotlin Coroutines for Android Development, which contains more than 9 hours of high-quality video content and is therefore probably the most extensive and in-depth resource about coroutines on Android. If you are interested, please check out the link in the description.